Oops. After this first graph, we'll be using Desmos to visualize things, but I want to try and get you to visualize it yourself. First here, so there's 0, 0, 1, comma 1, 2, comma 4, comma 9, negative 1, comma 1, negative 2, comma 4, comma 9. Okay. I'm going to bring out my trusty rusty ruler right now. I'll give you a second to finish the graph. Because when we talked about the difference quotient, what were we actually looking for? Let's go to anybody here. When we first made the difference quotient, what were we looking for? What was the instantaneous rate of change? What was the difference quotient of it? Think back to advanced functions if you can't remember this here. Go ahead. Slope of the tangent, that's exactly what it was. So what we're going to try and do, we're just going to estimate the slope of the tangent all the way through. I'm going to estimate it with a meter stick, just to see. So if you remember what a tangent is, it's going to be a single line like this. Now, if I had to guess what this was, is that positive or negative, this slope? This is going to be very negative, okay, like negative a lot. So if I could call the negative a lot, I'm going to put it right like this. That slope is very small, okay? So the slope, let's say, is negative 7, negative 8. So as I go from here to here, what's happening to my slope?
It becomes less negative, but still negative.
It's still negative, so just if we didn't see because my back was in the way, it went from here to here. So it's still a negative slope, but it's becoming less negative. So let's call that maybe, I don't know, negative 4, maybe negative 3, we'll call it. Okay? So as we're going from here to 1, what's happening then again? My slope. From here, sorry? Good? Even less. So I'm going to call that somewhere down here.
Wait, is this just random points, or are you?
I'm just estimating. That's all I'm doing here.
Okay.
Okay.
So
We're going to find
would it
things.
be mirroring or no?
Sorry?
Would it be mirroring it? Or?
No, it's not going to be a problem. So let's go down to here. What's my slope here going to be?
It's going to be
0.
0.
0 is what it's going to be. Okay. So then, as we get up to here, what's my slope here going to be? Positive. In fact, it's going to be the opposite of what this was. So let's pretend this is negative 2. Let's just pretend this slope would be positive. Okay, we can follow that logic. Okay, and if this slope was negative 5, we would say this slope would be positive 5. We're okay with that logic? Okay. So it looks to me that the points are sort of going to go like this for the slope. What does that sort of look like if you twist your head? It sort of looks like a line to me. Okay, can you follow that if I say it's a line, in fact? Okay, and we'll actually do the calculation to see. But as you're going to the right, the slope is getting higher and higher and higher. As you're going to the left, the slope is starting up high, so very, very negative, getting less negative, less negative, less negative, less negative. We're okay with that concept before I move on? Okay, I'm going to show you what it actually looks like. Okay, oops, if I can find my thing here. Not that one. This one. Okay, so my original graph was f of x equals x squared. That's a lovely looking graph. Okay, this is actually what the equation of the, we'll find this out in a sec. 2x is what it's going to end up being. Okay? So again, you're seeing when you're starting here, the slope is very small. So the slope here technically is -6. Okay? Then you get to -2, it looks like the slope is -4. Again, we could calculate that if we needed to. -1, it's getting more and more and more. Okay? So we'll go through this and we'll actually do this by hand, and then we'll move on to more complicated functions. Okay? But that's what we're calculating here. We're finding the value, the equation for the slope is going to be, it looks like here, 1 degree less. Okay? So let's do an example just to make sure we can do it with algebra. You can sort of figure it out with pictures. So we'll example on 1, I guess. Brad, let's start with you.
Yeah.
Perfect. Hey, Brad. Can you recite from memory or from your page? When I write f prime of x, what do you say, please?
Yeah. X plus 8.
Yeah, yeah. So I'm going to write lim x approaches 0, no, h approaches 0 first. Keep going.
F x plus h minus f of x over h.
Good. Now this should be easy pickings for you guys here. This for you guys should be the easiest thing in the world after what you've seen. And that's why I taught this unit how I did, that after all the limits, this should be straightforward. Calvin, can you show me how straightforward it is? What do I do now, please?
It's 7 x squared.
Yeah. And Caleb, what is x plus h all squared equal to, please?
X squared plus 2xh plus h squared.
Okay, now I'm just going to, thank you, Caleb, you're correct. For those people that are saying, wow, Caleb's amazing. And you are amazing, Caleb. Okay, let's not get it wrong. You are amazing. He got that so quickly out of his head. He either, one, he had it memorized. He could have also used Pascal's triangle. Remember we talked about that? Where it goes 1, 2, 1 for the coefficients. And we're going to talk about cubics and quartics today, where you're going to need the bigger things. But you are amazing, Caleb. I didn't just amazing for that. All right, Jason, what do we do right now, please?
Calculate the x squared.
Yeah, perfect, okay? Isn't this easy now? Like, this is like, after all that hard work, this is like super, derivatives are like easy. All right, so this turns into limit. H approaches 0, 2xh plus h squared all over h. All right, Teresa, why are we happy? Good. Okay. And Austin, my final answer is? Okay. If you think you know how this works, you still have to show all this work on your Unit 1 test. I'm looking at one person when I say this, okay? But if you think you know shortcuts and things like that, you have to give me this on your first test and assignment and all that, okay? Okay, are we feeling okay about this before we move on? Yes? Okay. I'm going to go to Desmos, and I'm going to do some algebra. I'm not going to make you graph this by hand. Example 2 is going to be, sorry, does anyone need this? Anyone need this one? Example 2 is going to be f of x equals, sorry, Chris, do you have a question or that was an answer? That was an answer before or a question?
No, I'm good. But on the topic of it, whether it gives you f of x or
dy by dx.
then that's what you use.
Yeah. Yeah, you can use the same one. I'm not picky on the formula. If you get them mixed up, that's fine. Okay, so this is going to be our question right there. F of x equals negative 3x cubed plus 2x. Let's talk about slope. In this segment, what's happening to my slope?
Negative.
It's negative slope. What's happening to it, though? Go ahead. Yeah, it's becoming less negative. So it's going to be something like this, becoming less negative. At this moment right here, what happens? it's 0. So it's going to look something like this. What's the slope from this point? Positive. So it's going to go right here to 0, be a little bit positive. What's the slope here happening then? Negative. So I'm guessing when I do this, it's going to come through here, hit 0 here, come positive, hit 0 here, and then come back down. What shape did I just make with my mouse?
Problem.
I did make a problem, right? So it's going to hit 0, hopefully, right here. Hit 0, hopefully, right here. Okay, so positive slope. Even though it's downward opening, it's still positive in this little section, right? Let's see if we can actually get an equation to match that, though. Do you guys want to try this by yourself? Okay. Now, just as a reminder before we start, that I'll write the equation on the board. Sorry, I'll write it on the board. For example 2. Just a reminder for cubed. How do you do cubed? And I'm going to pick on Caleb again for this one. Caleb, if I cube something, what is the coefficients going to be?
Is that like the, what do you mean?
Like if I expanded 8. I'll give you guys a second. Forget it. Try it out yourself. Try it out yourselves. Okay? I'll pause this. Try it out yourself. If you need help.
So for this one, what does is that like the inverse?
No, not at all.
So the ones with the 2x.
That's just an addition to it. So that's going to be part of your